This is the podcast for Group 17, and the project title is EMC EMI Compliance Testing of an Amplifier Module for a Reconfigurable Set-top Box based on Software-Defined Radio. The project objective was to investigate radiated emissions of an amplifier module for a reconfigurable set-top box using software-defined radio technology for digital television reception. The objective was achieved by modeling the device in COMSOL and the device under test and required parameters for modeling the EM behaviors that the device might employ were defined. The testing was performed using standard BSEN 550022.
According to Jeffrey Mills from the Illinois Institute of Technology, many of these devices, such as oscillators, digital logic circuits, and switching regulators, radiate electromagnetic fields unintentionally. The Vice President of Finest Solutions, Alpha Riddle, claimed that these devices commonly interfere with other devices, and this interference is known as electromagnetic interference. The term electromagnetic compatibility is used to denote the study of EMI effects. Standards were developed to alleviate interference. A major difficulty with electromagnetic field measurement is repeatability of results, as any materials in their vicinity can affect the fields. One particular test that can be done is an open field sight test. An open field sight eliminates reflections and external field sources, and one way to eliminate the effect of these straight sources is to perform testing inside a shielded enclosure.
Now, let's look at the EMI testing done within COMSOL. First, the device under test geometry was defined using the basic geometric shapes within COMSOL. The dimensions were specified from the PCB solution. After, the materials was then specified within COMSOL, such as the circuit board material, the air material for the spherical boundary, and the copper for the PCB copper traces. After all the materials and the geometry was defined for the device under test, the physics of the device under test was to be modeled. The device under test was required to take a radio frequency signal and amplify that signal by a gain of 20 decibel and output the amplified signal. Therefore, the external current density was used in the electromagnetic wave frequency domain to show the current density signal flowing through a PCB trace in the X direction. This PCB trace was calculated by using the maximum rated current for the PCB trace and dividing it by the area of the PCB trace design. The second for the output PCB trace was just multiplied by 100 to show the simulated amplification. After these parameters were defined, the COMSOL module was meshed at a normal rate, and then the results was then computed. Looking at the results, we see that the PCB trace output emits an electric field greater relative to the input PCB traces because of the amplification of this inputted signal. Let's look at the contour lines. As we decrease the frequency of the signal, the electric field intensity contour lines also decreases, and same for the actual electric field. As we decrease the frequency, the electric field also decreases. As we extend the view, we see that the electric field emitted are negligible at the boundary. Therefore, the electric field do comply to the EN 55022 standard, as the electric field at one of the boundaries are at 0.47 microvolts per meter, where the standard was 32 microvolts per meter. Therefore, the electric field at the boundary was below the required standard. Hence, the device under test does comply to the EMI standard.